everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation by eliminating f from z equal to f of xy by z. We are asked to form a partial differential equation by eliminating this f from this equation. Okay, given z equal to f of xy by z, consider as equation number 1. Now let's partially differentiate it with respect to x and also with respect to y. We'll begin with x. Okay, we'll partially differentiate 1 with respect to x. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of 1. This gives us dou z by dou x equal to partial derivative of f of xy by z is f dash of xy by z into inner derivative, that is dou by dou x of xy by z. Since we are partially differentiating with respect to x, so we can treat y as constant, this y as constant. Okay, and also we have a notation dou z by dou x equal to p, right? Let's replace it by p, then you'll get p equal to f dash of xy by z into constant y into partial derivative of x by z. Right? This gives us p equal to f dash of xy by z into y into partial derivative of x by z. That is dou by dou x of x. Here we are going to apply u by v whole dash formula, which is u dash v minus v dash u by v square. Okay? U dash into v, that is z, minus v dash into u by v square, that is z square. Now this gives us p equal to f dash of xy by z into y into partial derivative of x with respect to x is 1 into z minus partial derivative of z with respect to x, dou z by dou x into this x by z square. Okay, this gives us p equal to f dash of xy by z into, since we have a notation dou z by dou x equal to p, so we will replace dou z by dou x by p. We'll get z minus px by z square. Okay, now consider it as some equation number 2. We have considered the given equation as equation number 1, right? So let it be 2. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1. Since we are partially differentiating with respect to y, so we'll treat x as constant here. This gives us dou z by dou y equal to partial derivative of f of xy by z is f dash of xy by z into inner derivative, that is dou by dou y of xy by z. Since we have a notation dou z by dou y equal to q, let's replace it by q. We'll get q equal to f dash of xy by z into, since we are partially differentiating with respect to y, so we'll treat this x as constant. So we can write this term as x into dou by dou y of xy by z. Okay, fine. This gives us q equal to f dash of xy by z into, take this x outside the brackets, you'll get x into, we have taken this x outside, right? So you'll get y by z here. Again, we'll apply u by v whole dash formula, which is u dash v minus v dash u by v square. This gives us dou by dou y of y, that is derivative of y, derivative of u into v, which is z, minus derivative of v into u by v square, which gives us q equal to f dash of xy by z into x into partial derivative of y with respect to y is 1 into z minus dou z by dou y into this y by z square, which gives us q equal to f dash of xy by z into x into z into 1, z minus, you can replace it by q, since dou z by dou y is q, we'll have qy here. Consider as equation number 3. Okay. Well, now we have equation 2 and 3, which involves f dash of xy by z, right? Now let's eliminate f dash of xy by z from these two equations using 2 by 3, which gives us LHS of 2 by LHS of 3 equal to RHS of 2 by RHS of 3 where f dash of xy by z gets cancelled and this x square also gets cancelled, and you'll get p by q equal to y times z minus px by x times z minus qy. Okay, now let's simplify it by making cross multiplication, which gives us p into x into z minus qy equal to q into y into z minus px. We'll get pxz minus pqy equal to qyz minus pqx. Okay, here you're having x also, right? So you'll get pqxy, and here you'll get pqxy. Sorry for the mistake. Now we can cancel minus pqxy minus pqxy from LHS and RHS, then you'll get pxz equal to qyz. Again you can cancel this z. Okay, directly you can cancel z, or just you can take this z to RHS, like you can just carry this z to RHS, then you'll get, right, where z gets cancelled, and you'll get px equal to qy. This gives us Px equal to Qy. Therefore, Px equal to Qy is a required partial differential equation. Which completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.